Okay, in today's lesson, we'll be studying activity 2.5 and continue our work with variables and problem solving. In this section, we'll be studying like terms and how to combine them, and we'll use the distributive property to do that. So let's look at the distributive property. The distributive property lets you multiply a sum of terms inside a parentheses by a term outside the parentheses separately, and then add the products together. So let's look at an example. If I want to multiply 5 times the sum of 7 plus 2, I can multiply the 5 times the 7, and then the 5 times the 2, and then add those two products together to get the answer. So I would have 5 times 7 is 35, plus 5 times 2 is 10, and the answer would be 45. Let's look at another example of the distributive property with variables. I want to multiply the sum of 8 plus 10 by the variable p. So we'll multiply p times 10 and then p times 8 and add those two together, and we would have 10p plus 8p equals 18p. You'll notice that I've underlined p times the sum of 10 plus 8 is the same thing as 10p plus 8p. Those are equivalent expressions. Here are two more examples of the distributive property. You can see that you can have more than two terms inside the parentheses, and you can have a number and a variable outside the parentheses, but the process is still the same. You multiply the number outside the parentheses by each term inside the parentheses separately, and then add their products together. Now let's get into the lesson, which is about like terms. Two terms are called like terms if they have the same variable raised to the same power. Some examples of like terms are 4a and 7a, and 19m squared and 26m squared. Those are like terms. These are not like terms. 7x plus 9x cubed are not like terms because one has an exponent raised to the third power, and 4q and 10p are not like terms because the variables are different. Now let's look at how we can combine like terms, add and subtract them. And we do this by adding or subtracting the coefficients of the variable. Remember that the coefficient is the constant multiplied by the variable. So let's look at these examples. If I want to add 30x plus 6x, I add the coefficients of 30 plus 6, which is 36, and then I add the x. If I have 89m minus 16m, I subtract the coefficients 89 minus 16, which is 73, and then I add the variable m. If I'm adding 3a plus a, I'm adding 3 plus 1, which makes it 4a. Remember that if there is no coefficient present, it is understood to be 1. So you can see that in these examples, we're applying the distributive property in order to add or subtract the coefficients together. Now let's look at some more examples of combining like terms. In example A, I'm combining 5b minus 2b plus 10b. Again, I'm going to combine the coefficients of the variable b. So I would have 5 minus 2 plus 10 equals 13 times the variable b. In example B, you'll notice that there are two variables in the problem. But you can move the terms around in order to get the variables together so that you will be able to combine them. So in my problem, I have 9x plus 3y plus 5x minus 2y. And what I want to do, because addition is commutative, I can move the problems around, I can change the order. So I'm going to change the order and write it as 9x plus 5x plus 3y minus 2y. That way I have the x's together and I have the y's together. So then I can do 9x plus 5x is 14x, And then I have 3y minus 2y equals 1y. So the answer is 14x plus y. In the third example, there's a constant term at the end, which cannot be combined with any of the other terms. So we just combine the like terms and we add the constant to the end. So I have 6a plus 5a plus 3. I add the 6a plus 5a to get 11a, and then I just add 3 on the end. We'll be doing some more problems like this in class, so you'll get a better understanding of how to move things around and how to combine like terms. We can also solve equations using like terms. We combine the like terms first, and then we apply the fundamental principle of equality, which we learned in sections 2.3 and 2.4, to find the value of the variable. So if I want to solve for x, and I have 3x plus 9x equals 72, I combine the like terms. 3x plus 9x is 12x equals 72. And then I divide both sides by 12, which is the coefficient of x, and I end up with x equals 6. Here's another example of solving an equation with like terms. I'm solving for y. If I have 16y minus 4y equals 132 is my original equation, I can combine 16y minus 4y to get 12y equals 132. Again, I divide by the coefficient of y, which is 12. So 132 divided by 12 is 11. So the solution is y equals 11. Here's one last example of combining like terms to solve an equation. We're solving for n, and my equation is 32 equals 4n minus 3n plus 7n. I combine the like terms of 4 minus 3 plus 7 to get 8. So my equation is now 32 equals 8n. I divide both sides of the equation by 8, which is the coefficient of n, and 32 divided by 8 is 4. So the solution is n equals 4. This concludes section 2.5. And again, we'll be going over more examples in class so that you'll be able to apply what's in this presentation to solving problems.